I'm going to present. So this talk I have lined up today is going to partly be about the research I conducted for 6 months on the RTF spec and some things I learned about it that would be really useful for both blue team and red team alike. My favorite slide, the slide where I talk about myself. Currently, I serve as an engineer on IGZIA's ATI team. So we do a bunch of exploit development and malware analysis. I'm a proud DSU graduate, so I know I got some friends here today supporting me. I appreciate y'all for showing up, and I definitely love CTFs. Hi, Jake. So I mentioned there's going to kind of be two elements to this, right? Blue team and red team. So for all my blue team friends, here's the key points that I think that you're going to get from this, and that's going to be kind of understanding how to analyze malicious documents, the capabilities, the red flags to look for. So those of you that are maybe responsible for writing signatures, hardening desktops, right? I think you'll get a lot from this. Now, if you're on my favorite team, the red team, the key points here are going to be obfuscation techniques. So I've heard some pen testing friends complain about, hey, what are we supposed to do now that macros are all locked down pretty well? Like, what other options do we have? And I think we'll quickly find out that the RTF spec provides some options for you to still be effective in your engagements. For those in vulnerability research, we'll go ahead and actually revisit the work that I've done and just laugh together at how Microsoft literally hands you the blueprint to finding vulnerabilities. We'll finish up with some exploitation techniques, and I do know that there was a title change. We talked about exfiltration. I'm going to talk more about like the possibilities. When you're coming up with a talk title, it's like everything needs to kind of flow and rhyme. So what can I use for exfiltration? Yeah, it's possible, but how practical is it? Well, it's up for you to decide. So that said, let's talk about some of the features that RTF supports. And it's pretty interesting. So you can define your own custom variables. It supports OLE, object linking and embedding. You actually have the ability to even query databases. So when I saw the mail merge functionality, so maybe old mail administrators are probably more familiar with this, I was like, that's crazy. I didn't know that I could actually perform a query to reach out to either a flat file or a database and pull information back and record it. The rest of this stuff over here is kind of, what you would expect out of some type of feature-rich markup language. For those of you that are, maybe not red or blue team, but it kind of affects us all, like why should we all care? We see this a lot in phishing campaigns. So previously I worked at a couple of banks, and phishing is just the way the bad guys win, right? It's the path of least resistance, and I think it always will be for quite some time to come. Its roots are pretty old, so RTF as a spec goes back to 1987, so like a year after I was born. And it's one of those gems I don't think too many people focus on anymore, because we already have, or Microsoft already has a new standard for you, which they like to see you save and use documents. And as we'll see later, it has a pretty wide attack surface. So to give you an idea of what an RTF document looks like, it's pretty easy to understand. So for contrast here, I thought I would take something I think most of us might be familiar with as HTML and show you that this is what, a hello world in bold would look like, while also including a picture of a cat. And then if we wanted to translate that into how it would look for the RTF spec, it would look as we see at the bottom. So key things to kind of take note of, the magic file header, so \RTF and then a version number. We have \B to just say, hey, we're going to, sorry, I'm trying to dodge out of your way, \B to say, hey, we'd like to bold this text, hello world. And then finally we have a picture object. So to jump right into the evasions, I started with the evasions because for our product, we actually have to take some type of exploit and we have to show our customers how many different ways can we make this look different yet still achieve the same result? So I did a study. I went and grabbed all of the RTF documents I could from the beginning of the year to about the end of June. And the evasion test was file extension tampering. So I'm sure many of you have seen this a lot where it's really an RTF document, but the extension says .doc. What you can actually do is, to talk about the study first, is most of the extensions that were RTF documents were actually all .doc, and I'm thinking that maybe people are more familiar with it, easy to associate with. Maybe some people don't know what an RTF extension is. About 100 of them were actually just RTF extensions. Less than 10 were docx, which that's not going to work. And then there were 300 other random extensions that really didn't seem to do anything because Windows, by default, when you install it, won't actually associate these other file extensions with Microsoft Word. So I decided to go ahead and look at what are all the different ways that we could possibly just tamper with that one piece to possibly gain some new ground. So there could be, like at your mail gateway border, hey, we're going to maybe drop certain types of file extensions. So you could literally go ahead and rename an RTF document to doc.wbk for workbook and .wiz, and it's still going to go ahead and run your RTF payload. The next thing I looked at is magic file tampering. So at the beginning we saw it was \RTF. Well, we rely on these magic file headers or magic numbers, if you will, to help understand, well, what type of file is this going to be? So it's funny because we'll see this later that the specification says that it needs to say \RTF followed by a version number. However, in Microsoft Word, it actually only requires \RT. So as far as what can we gain from this for the blue team here, let's already look at now changing what our magic file magic file header looks like. Another thing that I looked at is like using mixed case, and I'm not really gonna try to beat that one to death because I think these days a lot of our detection technologies are really good at looking at whether or not you decided to uppercase or lowercase something. Where I was able to get some big wins as far as bypassing things is in regards to evasions, encodings. For those of you familiar with URL encodings, you're used to using like %41 to represent an A, or if it's WRL encoding, %2541. Well, the RTF spec also supports Unicode and hex encoding, and you can automatically see it by when it's Unicode, \U followed by 4 digits, and then if it's hex, / single apostrophe and 2 digits. To give you an idea of what that looks like in the wild, we have just, wow, okay, I already know you guys can't see that. Sorry, that looked a lot bigger. That's what she said moment, by the way. Effectively, what had happened was a researcher had wrote about a new malicious RTF document, and they had used for their magic file header \RT VPN, and it was crazy. It was like, man, VPN, what does this mean? Like, why does this work? And eventually, you just start taking bites away to understand what's the minimum required. So that's why we were able to define what's that new minimum requirement. Some other things, and I know I'm talking to these now, but I'll be demonstrating some of these later. Bin substitution. So by default, when you look at, I'll use like packager objects for example, because we see those pretty commonly in the field. You'll see that a binary may be shown as a hex stream, but you can use bin substitution to define, I want to represent these next characters as ASCII characters that would represent their binary representation, as opposed to as you see it in a stream. Wow, this keeps sliding off. The other really effective, probably one of the most effective evasions that seem to work very well is just using whitespace to chunk up your malicious RTF document. So I think I got a couple more here, and then we'll get back to looking at more examples. So this one, I kid you not, is probably my favorite because it takes advantage of the RTF spec in the manner of which other people can introduce new words. So we saw there was a picture object, right? We know it makes a picture. If you were to develop an RTF reader and said, I want this control word or, this word to mean to do something else, well, we can take advantage of this by defining our own. So here we define a simple hello control word, and essentially when Microsoft Office goes to read it, it's going to look in its table and say, hey, do we have this tag? We don't, so skip it. But we can use this to literally just keep inserting this in different places in our document to help obfuscate it. So when you go to maybe test your payload against whatever AV, use this technique to kind of help break up whatever your payload is, and it's still going to run just fine. Hey, this looks a lot better for some reason. So here's just a couple more. An example of the bin one here. What's really unique about how the attacker used this one is that bin followed by a number specifies, here's how many bytes afterwards I need you to go ahead and treat these as ASCII characters. But here they specify zeros. They specify a lot of them. And basically, what you're allowed to do is have a certain number afterwards, and effectively it's like a null. And then I mentioned white space obfuscation is also really powerful. Here is another payload where what they did is after they embedded whatever their payload was, they just started hitting enter after every single character. The consequence is, well, you kind of bloat your file a little bit. It's a lot larger, but the effective piece is, well, now it's flying by multiple detection controls onto its destination. Talked about some evasion stuff there, and I'm going to flip over to VM. Just to kind of give you an example, Okay, so two things here, just to kind of demonstrate the effectiveness of evasions. I'm going to go ahead and take a popular tool called RTF scan. Not sure of those of you that are familiar with this tool. But basically, we can go ahead and scan, a malicious RTF document. Now, this one, it's PowerShell, so it's really going to have a low index rating, as especially pen testers are aware. PowerShell is basically king in most environments. So what I decided to do is, all right, well, how could we obfuscate this in a manner that would simply bypass even this tool? So I've already done it, and we'll take a quick peek at it. I went ahead and just scanned a different file. We're going to take a look at that, but we see that analysis is finished. There's no malicious traces now. And how are we able to easily defeat this? Well, as I said earlier, it's really all about using fictitious control words. So what I've done... Oops, I know that's not helping. I really don't want to lose my laptop when I turn my back. What I've done here is we have the object data tag, and that basically says, here comes what's expected to be treated as binary. So every two characters here. And I just started inserting my own made-up control word called meow. I just started just placing it in random places, right? Meow, 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 meow. Scan again. Again, we've broken up how these scanning tools work, and now we're effectively bypassing that. Now, to an analyst that can see the source, I think they'll look at this and understand that, all right, well, I do know that I have some type of embedded data here, and they would still extract this and move forward. I'll be releasing some new research that actually will go through comparing it against all the other tools out there, such as Didier Stevens just released a new tool called RTF dump. There's like three other ones out there that are pretty nice, and it would just be cool to try to understand how effective is this in the long run. So to demonstrate some more, I took a known malicious file, and I was like, all right, I'll just send it through an obfuscator tool just to see what can I get out. So this is a simple sample that I pulled, and we could see there's 32 detections. And I was like, if I just do some simple things, like what do we think we can reduce that number to? And mind you, the way my tool works is pretty random, and we reduced it down to 20 first roll. I've actually have done exercises like this, and you can get to 0. Trust me, you can. It's just you got to understand where is it based on the AV that you're looking to bypass. Like, where do you need to properly insert some of these things? So let me go back to the slides. Help. All right, so vulnerability discovery. I don't know if anyone here was in Jared DeMott's advanced exploitation course, but he gets this question a lot. And as a security researcher, what can I go after to try to find bugs? And he says, find something as old as you can that's written in C. Well, that kind of really fits the description here, right? 1987, that's quite a while ago. And I believe it was 2008 they released their last update on the RTF spec. So let's look at how do we use this to help us as security researchers understand where do we want to fuzz. And the key to this is just search for the word must. They use it so much, like you must do this, you must do that. If you want to format this, it must look like this and that. And just kind of reading through some of these, the list ID one. So there have been plenty of bugs found that abuse list IDs. And if we look, it says that each list must have a unique list ID that should be randomly generated and is a long integer, and a list ID cannot be -1 and -5. So as security guys, what are we going to try to do? -1, -5, right? So I'm not going to beat this down all day, but please take a look at the spec. It's pretty fun to read, and it's really simple. It's like HTML. So for those of you maybe looking at trying to discover vulnerabilities, it's really easy to get up and running and creating your own data models. And we'll talk a little bit more about that here soon. So my tool of choice for my fuzzing was to leverage the community edition of Peach. And there's basically kind of two approaches to this. You can take a mutation-based, for those of you that may use something like WinAFL, where you can just hand it your test case and say, hey, mutate this one at a time until hopefully we get a crash. Then there's generation-based. This is where the spec was very handy because you take a look at how something is supposed to be constructed and you adequately model that. So to demonstrate this, I actually built a very thorough data model, and I literally ran over 2 million iterations, and it was really slow because I would restart Microsoft Office every time. And if you can imagine, distributed amongst 6 VMs, really low resources, it wasn't as fast as I wanted it to be. But I got over 500 crashes, 6 of those unique, and hopefully penned in some CVEs. So I'll make it a short demo. So this is, this is horrible is what this is. Sorry, the scale. But basically what we do is, okay, so I have a data model called RTF all the things. I found every single tag I could and said, let's take these and allow Peach to create them and mutate them according to whatever strategy we want. So you properly define your header, you add a tag, and you begin mutating. I should still have a... Whoa. Can't see over there. So this is just an example of what would be generated, and it will try to add more tags, less tags, to achieve some type of crash inside the software itself.
So it's generating that file, and then you open that with.
Correct, with Microsoft Office. So I mean, I could. If I could, I mean, yeah. Well, I don't have to. It's kind of like it's awesome. It's kind of like fishing. I don't know if anyone here likes fishing. I love to go fishing. I like, fishing in the security sense and the real sense of the word. It's kind of like set it and forget it. So once you build this, you just, you cast your line, and, every morning you'll check, be like, we got a fish here, we got a fish here. Yeah, yes, no. I thought I was running this whoops. There we go. So this is what the process looks like, right? So it's going to create a new test case, open it up in Word. You may not see Word fully open every time. Wow. So look, we just caught something. That's not by design. I'm telling you, it's not. But this is typically what it looks like when you get a crash. So wow, we may have a new submission on our hands. That's actually really cool if that turns out to be the case. Promised you it's not staged. I'm actually going to let this run because I really want to see that. We'll come back to it later, maybe to check on it. But this is what the process is like, where you go ahead and please reproduce. I'm getting distracted. Please reproduce. When I say reproduce, like, is it luck, right? Was it just a coincidence that it just happened to crash once? So you always want to try to reproduce your bugs. That way they're easy to analyze, understand, are these exploitable or not. Oh, this is a real painful position to be in. So, kind of moving on. Wow, 20 minutes. Need to fly here. Some food for thought. I spent 6 months fuzzing Microsoft Office 2016, and I did it just on the Windows platform. But if the creator has its flaws, how about the imitators, right? So think about other applications that work with RTF documents. What could we possibly find there? And I'm convinced on some things I've tried that Android is going to be the next platform I decide to test against, because I'm already seeing some pretty interesting results. But also think about maybe cloud-based services that may take this in. So I mentioned that the packager DLL is pretty much one of the better options for getting around issues with macros. And how it works by default is you simply open up your document, you'll go to Insert, select Object, and then pick whatever it is you want to try to get the user to click on. You're going to run into some issues, and that is that Packager checks for certain extensions. It didn't used to be as great as it is now. I'd say 4 years ago, you could even do jar, a couple of other extensions, and it wouldn't even tell you anything. It would just start running it. So here's how that process looks. The packager DLL will actually call the shell W API to run a series of checks, and those checks are to first get the path extension, because it doesn't care what you name. It just wants to know, based on this extension, is this a risk? And there are a lot of hard-coded checks that it goes through. But as I went through these, and as you can see here, this is from IDA, here the hard-coded list of things that it checks for. I didn't see certain things like PowerShell and like Python, like other kind of scripting languages. So digging further into it, then it'll actually go and query, like based on that file extension, it'll look in the registry. And it's looking for a special flag to see, is it safe, always dangerous? There's a couple of them. And if it doesn't find anything, by default, it will still give the user one courtesy warning. Unfortunately, there's no real way to bypass that either via the obfuscation stuff that we saw earlier. Thankfully, though, there's a way around that, and you can forge images. And it's really simple. Go ahead, take any image you want, save it in Word, and then save it as an RTF doc. You'll just open it in your text editor of choice, copy that picture object, and replace it with whatever you get when you embed anything else. Then, when the user goes to open it, they will effectively see something else. I don't think that's, well, looking at the time, if others want to see that, I'll gladly demo that. We can meet up outside. So, moving on to the exploitation side of the fence. Outside of the packager object and also using maybe hyperlinks to invoke the MS Word protocol to maybe retrieve something from the web, you really only have the AutoMagic stuff. So maybe whatever's in Metasploit, these are two popular CVEs. Insecure library loading. So those type of vulnerabilities still pop up from time to time. However, looking at firewalls these days and how the egress stuff's getting locked down, I'm not sure how viable that will be. And I actually have a funny story that's probably going to have to be for afterwards, but I'll mention it in failures because I did fail a lot. A way to actually get around that, and it's more like a self-contained way to proc those type of vulnerabilities. This is the best tree I could produce based on today. What type of CVEs can the RTF spec take advantage of? And I only included those that directly affect Office and insecure library loading vulnerabilities. I didn't include something that I should have because it's been used in popular nation-state malware, and that's embedded font type. So I have another demo here for you. Doing okay on time? Oh, I'm over? It's okay. Be quick here. So this might go kind of quick. When you embed something, you have I know there's not enough memory. Here's what I meant by we can actually take a picture and overlay it here and make it look like whatever we want. So I noticed that there's a way to get around that first check, that courtesy check, and that's if you have a kernel level vulnerability. So I took Juru's simple proof of concept that he put out on the internet, and literally just by double clicking this, boom. So if you have kernel level payload or whatever, instant execution. They don't get a pop-up or anything. Now, I'm not advanced enough to write something like that, or I would have gladly demoed it for you, but it's important for us to understand, what are the possibilities? How could a potential security control fail us? So that VM's going to heaven. Nope, I'm just about to wrap up here. Yeah, I have a lot. So for countermeasures here, blue team, for those of you that write Yara SIGs, don't look at, /RTF, just look for /RT, preceded by an open curly brace, of course. IPS IDS rules, I really don't have anything for you. It's kind of a joke. For those of you that are in charge of maybe administrating systems, look at actually switching the kill bit on the packager CLS ID. So that way, if you do deliver it and they try to run it, it's immediately denied. You can also change how you associate .rtf docs. So if you go to Start, Default Programs, you can actually see hey, how are things associated? If I click on this extension, what opens up? For fun, go ahead and just change it to just WordPad. I mean, WordPad seems pretty simple, or even Notepad if they really need it that bad. Of course, that's all about what all you really need, right? For some people, it's pretty practical to do that, right? So coming from the banking industry, you could pretty much get away with that, but maybe in other areas you can't. So I mentioned failures, and I'll talk about those really quick, because as another researcher taught me, it's always important to acknowledge your failures, and we will close. I talked about triggering insecure library loading automagically, and here's an interesting caveat. So you can make something persist on your target host in their temp directory if you first embed your object, then place some type of POC to go ahead and crash Word. What happens is the packager DLL doesn't have the opportunity to, kind of clean it up and remove that from the target environment. So by embedding the DLL that would trigger that and a crash, it will go ahead, the DLL, and then you'll need another RTF document that you'll want your victim to click on, then the crash. So the first time it happens, nothing's going to happen. You're betting on that second time for it to happen, for it to pop. Another failure that I, personally failed at is porting embedded font vulnerabilities. I showed you the Juru thing as a embedded object. You can actually convert, these font types into actual embedded fonts. And I'm hoping that pretty soon here I'll be able to get the programming right to get that done, so that by default now when they open the document, there's no user interaction. It's just click and go. And then the last thing I tried is using byte order marks to kind of throw off any type of detection system that's banking on seeing \RTF first. And that was unsuccessful because Office doesn't care about that. So, yep. Nope, that's it. We really don't have any time here.